All right, year 9s. So far we have looked at, given a right angle triangle, how to find either the opposite, or the adjacent, or the hypotenuse side lengths. Okay? The way that we have done that is we have said, all right, if we give you an angle, say 10 degrees, and we give you one of the side lengths, say 4 meters, how do we find the unknown side length? What we're going to look at now is what happens if you are given 2 side lengths and asked to find the unknown angle of theta degrees. Okay? We're going to be using the same 3 ratios, sine, cos, and tan, but this time we're going to be using what is called the inverse of each of these. So, we're going to be looking at sine inverse, cos inverse, and tan inverse. So we know that sine of theta degrees is equal to opposite over hypotenuse. Sine inverse of opposite over hypotenuse is equal to theta. We know that cosine of theta degrees is equal to adjacent over hypotenuse. So cos inverse of adjacent over hypotenuse is equal to theta. And finally, we know that the tangent of theta is equal to the opposite over adjacent. So that same opposite over adjacent, if we use tan inverse, will give us theta. So just to highlight for you, this ratio is now going inside the brackets. Okay? The adjacent over hypotenuse for cos is going to be cos inverse of adjacent over hypotenuse. Same thing for tan. So long as you know this ratio, you can find its inverse and use that to find the angle. Using this current example, the first step is still the same. We still label all 3 sides. So we know that this is the opposite, this is the hypotenuse, this is the adjacent. We still look at what is given and what we are looking for. So we know that theta is something that we're looking for. So I'm going to leave it as theta degrees. We know that the opposite is equal to 3 meters. We know that the adjacent is not provided, nor are we looking for it. And we know that the hypotenuse is 4 meters. Now looking at this, I can see quite clearly that I need theta and I have the opposite and hypotenuse. So I'm going to be using sine. Because I am after the angle, I'm going to be using sine inverse. So the way I set it up is if sine inverse, which is represented as a -1, of O over H is equal to theta, and I know that O is 3 meters, then I can say sine inverse of 3 meters divided by my hypotenuse, which is 4, is going to give me my theta value. And I'm just going to put this whole thing straight into my calculator. Now, your calculator will have all 3 of these functions directly above your standard function. So if you have sine on your calculator, then when you press shift and then sine, you will get sine minus 1, which is your inverse function. So it is shift and then your sine function to get inverse sine. So I'm going to do this on my CAS calculator, but you can do it on your scientific. I'm going to put in the inverse of sine, 3 divided by 4, and I find out that that is equal to 48.59. So theta is equal to 48.59 degrees. I'll do one more example. You have a triangle, and this time we're going to have theta and alpha. So we're going to have two different angles. We know that this is equal to 10. We know that this is equal to 8. And we want to find out what these two angles are. Now, the first thing I'm going to do is realize that my opposite and adjacent will change depending on which angle I'm considering. So I'm actually going to draw theta in red, so you can tell when I'm talking about theta. And I'm going to draw alpha in blue, so you can tell when I'm talking about alpha. So let's start with theta. When we're looking at theta, this is our right angle here. When we are looking at theta, the hypotenuse is 10. The opposite is 8, and the adjacent is not provided. So I will list it. Theta degrees is equal to theta. Okay, and that's what we're looking for. My opposite is 8. My adjacent is not provided, and my hypotenuse is 10. I have theta, opposite, and hypotenuse. So I'm going to be using sine. Because I'm looking for an angle, I'm using sine inverse of opposite over hypotenuse. I'll just redo that so it looks like opposite, not theta. That is opposite over hypotenuse, and that will give me my angle of theta degrees. When I substitute sine inverse, my opposite is 8. So it is 8 divided by 10. And that is all equal to theta degrees. I put that into my calculator. So sine inverse of 8 divided by 10. And that gives me a final answer of 53.13 degrees is my theta value. Now for alpha, I'm going to have to relabel my triangle. Because if you're looking at alpha, this is no longer the adjacent side. That is opposite from alpha. So I'm going to remove my previous labels just to avoid confusion and relabel it. So for alpha, this is still the hypotenuse, but this is now the opposite and this is my adjacent. So when I look at what I have, my angle is actually alpha. That's what I'm looking for. My opposite is not provided. My adjacent is 8. And my hypotenuse is 10. Having an angle, alpha, adjacent, and hypotenuse, I'm going to be using my cosine formula, my cos formula. Because I'm looking for an angle, I'm going to use cos inverse of adjacent over hypotenuse is equal to theta. My adjacent value is 8, so I'm going to have cos inverse of 8 over my hypotenuse value, which is 10. I'm not actually looking for theta. In this case, I'm looking for alpha. So I'm going to put alpha there so I don't get confused. I'm going to put this all into my calculator. And when I do, I have cos inverse of 8 divided by 10 is equal to 36.87 degrees. And that is equal to alpha. So I now know that if I were to redraw this triangle accurately, I'd have 8 there, 10 there. This angle here would be 53.13 degrees. And this angle here would be 36.87 degrees. Good luck.